Research into black holes is still relatively new. Although predicted by Einstein's theory of general relativity, black holes were once definitively proven to exist in the 1960s. We got our first image in 2019. These dense spheres control star systems and entire galaxies and will destroy anything in their paths, even breaking time itself. But what happens when a black hole erupts? This is Unveiled, and today we're taking in an in-depth look at the incredible new theory that black holes are like volcanoes in space. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. You may be wondering how a black hole can erupt at all. Due to their incredible mass, black holes pull in everything around them. By their very nature, nothing can escape them, not even light. It is true that black holes do leak a certain type of radiation called Hawking radiation, but this is a complex phenomenon that exists on a quantum level. Due to quantum fluctuations, virtual particles pop in and out of existence all the time. They come in pairs of one particle and one antiparticle, the building blocks of matter and antimatter. Often, they annihilate each other, but sometimes they're pushed apart instead. When a black hole leaks, it involves virtual particles popping into existence near the event horizon, the boundary of no escape. Hawking radiation is a result of one particle falling into the black hole, while the other escapes. We have yet to conclusively prove that this happens due to the difficulties in observing black holes. However, if true, it means that eventually black holes will shrink and dissolve. Interestingly, physicists say that the smaller a black hole is, the more it will leak, and therefore the shorter its lifespan. However, even so, the lifetime of black holes is theorized to be immense. Research says that supermassive black holes have a projected lifespan of 1 googol, a number with 100 zeros. The universe is only 13.8 billion years old, so we're nowhere close to being able to witness a black hole dying in real time. The volcanic black hole eruptions that we're talking about here, however, are not driven by Hawking radiation. Black holes and other dense astronomical objects can produce massive beams of plasma called astrophysical jets. If you look into the night sky, you'll be able to see these jets for yourself, because they're the reason quasars are so bright. Quasars are supermassive black holes that produce such jets, and they're also the most luminous objects in the entire universe. If you know your constellations, you can see the brightest quasar visible from Earth, called 3C 273, in the constellation of Virgo. It needs to be a clear night, and you may need a basic telescope, but you can see this massive jet erupting 2.5 billion light years away. There are also blazars, which are basically just quasars with their jets pointing directly at Earth. However, they're not visible to the naked eye, since we're looking straight into the jets rather than at the beam visible from the side. Astronomers identified them based on the massive amounts of radiation they produce. Sometimes, these astrophysical jets produced by black holes can blast out material very close to the speed of light, at which point they become relativistic jets because they are affected by special relativity. Astrophysical jets are behind the eruptions that scientists have recently identified, and they are far greater than previously believed. Streaming out particles across thousands of light years, these jets generate what have been nicknamed cosmic bubbles of hot gas. They create stunning clouds and fields of gas that can be seen by telescopes, not unlike the beautiful nebulae left behind by supernovas. It's also these jets, which are made of heavily ionized matter surrounding the black hole, that produce the radio signals we associate with black holes. That's why black holes are active radio sources. Radio waves do not escape the black hole, but the material around it is so energetic that it produces radiation across the electromagnetic spectrum. The gas bubbles created by the jet expand and spread out, which is where the comparison to volcanoes comes in. Volcanic lava and other debris can spread extremely far from the source, sometimes hundreds of miles, but nothing compared to the bubbles erupted by the black holes, which stretch across trillions and trillions of miles in outer space. The scientists who published the research paper in October 2021 described these cosmic bubbles as transforming in time. They seem to have notable effects on the evolution of the galaxies around them. The jets and bubbles are moving so close to the speed of light that they actually create magnetic fields, which disrupts the clouds of molecules and matter, changing the way stars develop. It's not clear whether the black holes help or hinder the development of stars, and potentially, they could do both. The regions where stars form are made of dense clouds of hydrogen, and eventually, this hydrogen swirls together and begins to burn as it fuses to create helium. But the cosmic bubbles could get in the way of this, with so much fast, hot material preventing stars from being able to grow properly. On the other hand, once this material cools down, it could provide more of the ingredients needed to produce stars. It's clear that these jets and the phenomena they cause are in need of further study, but we can already see that they're massively important to the evolution of galaxies and the births of stars. NASA has even released photographs of one of these regions, a structure in space called the Green Blob. The Green Blob has been imaged by NASA's powerful Chandra X-ray Observatory, responsible for providing many incredible images of astrophysical objects invisible to the human eye. The Green Blob was produced by the jet of a quasar, though the black hole responsible has gotten a little weaker over the years. It's still an object producing a lot of energy, but not quite enough to be categorized as a quasar anymore. Space agencies and science researchers around the world are on the hunt for similar structures ever since the Green Blob's discovery in 2007, and the latest 2021 research into black holes' volcanic traits is a step towards imaging many more. It's not just black holes that can create beautiful structures like this, however. Not only do nebulas appear visually similar, some types of stars also produce jets, and therefore can have similar effects on surrounding space. Like black holes, neutron stars are immensely dense, collapsed stellar cores, but they're generally not as massive. Neutron stars with higher mass may collapse even further into black holes, but there are still plenty that exist out there in the universe. The ones that rotate extremely quickly are called pulsars because of the pulses of radiation produced in energetic beams. And neutron stars of all varieties have strong enough gravity that they not only gather massive accretion disks and produce jets, but enough that we can observe a large amount of gravitational lensing around them. Though neutron stars and black holes are all long dead, they all continue to have tremendous and chaotic effects on the galaxies they inhabit, much like a volcano's effects on Earth's environment. And that's the incredible new theory that black holes are like volcanoes in space. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.